This video, I'm going to talk about Cuda programming. Here, I have implemented the code with C and two vectors. So by default, this project contains the kernel file and the source code. So I replace the source code with my code. So I'm going to add my code here and let's look through my code. So here you can see there is a main function and there are three variables as ABC. So I initialize those ABC variables for this for loop, and after that we call to add vector function. So let's look at add vector function. Here when look at the add vector function, you can see the element of the vector A and the element of the vector B and add it together, and that is equal to the vector C. That means the main uh, result of this code is this one. So first of all, let's beat this code and let's see what is the output. Yeah, likewise, this is the output of our code. So you can see. So uh, though this is a CPU only code, that is not run in the GPU. So that means not in a CUDA project. So let's modify this code. That means we have to parallelize this function to execute it GPU. And for that, we have to specify the variables to access to the CPU and the GPU. And another thing, we have to specify launch configuration of the kernel function, and then this third, parallelize the kernel function to run on the GPU. So I allocate my variables using function called Cuda manage function here. So I change this one to Cuda manage function. So I copy this one and that one to this place and this place as well. And here I have to add B, comma, and C, comma. So then we can manage the variables in unified memory. So that is the function of Cuda manage function. So we can enable the variables in both GPU and CPU. In the malloc manage, return the pointer, so we can get it from the source and the device code. To free data from the unified memory, pass that value to pointer to the function cut free. So I copy this as well. I have to paste here. Order free. Yeah, likewise. Then the other thing is after that thing, we have to modify the add vector function. Here in the add vector function, the important thing is we have to add triple angle brackets in the first parameter. So let's take so first parameter is I take as what I take one as simplified to simplify this code, and the second parameter is size. So number of thread. So the first parameter is the number of thread blocks. So I use that one to simplify. The next is number of thread in each blocks. So the initialized size value is 1024. You can see here. So that value is equal to this one. Uh, so in this way, the CPU will wait until the kernel to complete, and CUDA device synchronize after the kernel launches. So after the kernel launches, we can use this. So we uh, write here CUDA device synchronize CUDA device synchronize. Okay, then finally, the final thing we have to learn is to do is to parallelize the vector and function. So here, so to do that one, we have to add that global keyword to here. So this tells that this execute the GPU at the host, and this function will run in many threads in parallel to identify what we can use read-only variables. That is, so I uh, initialize this as thread ID x.x. Okay, so they don't need to loop to run. So I remove this one. So instead of that, I use if I is greater than. So we can use if function to limit the operation in the numbers. Simple here. So that is the modification of our code. I think this may run properly. So let's build this code to see there's any error. I think there's no any error. So let's run this and here you can see we got the uh, same answer. That means now that is executed GPU as well. So this is the basic thing in the Coda. So thank you very much for watching this.